Students, today I would like to explain the second numerical from unit number 2, that is design of shaft, keys and coupling. So let us start with numerical number 2, that is design of shaft. So here the numerical is a transmission shaft supporting a spur gear B and the pulley D is shown in figure. The shaft is mounted on two bearings, that is A and C. The diameter of the pulley and pitch circle diameter of the gear are 450 mm and 300 mm respectively to the and the pulley transmits 20 kilowatt power at 500 rpm to the gear. Here P1 and P2 are belt tensions in the tight and loose sides, while PT and PR are tangential and radial components of gear tooth force. Assume here P1 force equal to 3 into P2 and PR equal to PT into tan of 20 degree. The gear and pulley are key to the shaft. The material of the shaft is steel 50C4, that is ultimate tensile strength equal to 700 and yield strength equal to 460 Newton per mm square. The factors KB and KT of the ASME code are 1.5 each. Determine the shaft diameter using ASME code. So here layout of shaft is given at the end A and D. For end A, the bearings A is mounted and on the pulley D, pulley is mounted. At the point B, gear is mounted and similarly at the point C, again bearing is mounted. So let us start to solve this numerical. The given data is ultimate tensile strength equal to 700 Newton per mm square. Then yield strength is given equal to 460 Newton per mm square. Then P, that is force load, is given as 20 kilowatt, that is equal to 20 into 10 raised to 3 watt. Then N is equal to 500 rpm. Then next, diameter of pulley at point B is equal to diameter of, that is pitch circle diameter of gear is given as 300 mm, that is, and pulley diameter dp equal to 450 mm, means radius of pulley is equal to 225 mm. Then KB and KT factor are given as 1.5 each, and condition is given that P1 equal to 3 P2 and PR equal to PT into tan 20. Then let us solve for next. First step is to find out the permissible shear stress with keyway effect. So according to ASME code, the permissible shear stress for shaft with keyway effect is, that is, tau max equal to 0.75 into 0.30 SYT or tau max equal to 0.75 into 0.18 SUT, whichever is minimum. So let us find out tau max equal to minimum value is here 94.5 Newton per mm square. Next step, second step is to find torsional moment MT. So for that purpose, we have to find out P1, P2, PR, PT and MT. So we know that the torque transmitted by the shaft given by P equal to 2 pi n into MT upon 60 into 10 raised to 3. So let us solve this equation by putting the values of n, P. We got the answer for MT, that is torsional moment, is equal to here 381.97186 into 10 raised to 3 Newton mm. Then next, find forces on pulley D. Here pulley D. On the pulley D there are two forces are acting, P1 and P2. So here find forces on pulley D. First of all, we know that the torque applied to the shaft by pulley D is given by equation Mt, that is torsional moment, is equal to P1 minus P2 into radius of pulley. Here we have already calculated the value of Mt, that is equal to 381.97186 into 10 raised to 3, that is equal to, we know that P1 equal to 3P2, condition is given, minus P2 into radius of pulley is 225. So let us solve this equation for P2. We got answer for P2 is equal to 848.83 Newton. But we know that condition is P1 equal to 3P2, means find P1 again is equal to 2546.49 Newton. Then next find forces on gear B. Here gear B is on the at the point B, gear is mounted, and here forces are PR and PT. That is, PR means vertical force, that is radial force, and PT means horizontal force or tangential force. So we know that the torque supplied to the shaft by gear B is Mt equal to PT, that is torsional or force, into tangential force into dP dash by 2, that is diameter of gear, that is P circle diameter. So here just put value of Mt, that is equal to 381.97186 into 10 raised to 3 is equal to PT into P circle diameter of gear is 300 by 2. So let us find PT, tangential force, here is equal to 2546.48 Newton, and we have one condition, PR equal to PT into tan of 20 degree. So let us find PR, that is equal to 926.84 Newton. The next step is the total tension on pulley D is, that is P1 plus P2, that is equal to addition of P1 plus P2, that P1 P2 we have already calculated, that is equal to P1 plus P2 equal to 2546.49 plus 848.83, that is P1 plus P2 equal to 3395.32 Newton. Next, an important step is to find the reactions and maximum bending moment using vertical loading diagram and horizontal loading diagram. So let us consider first vertical loading diagram. Here we have to draw the layout, that is we have to consider here vertical forces only and reactions at point A and C, that is RAV and RCV, and vertical force on gear B, that is PR, radial force is acting, and on the pulley D, vertical force, that is total force P1 plus P2 is acting. So let us find reactions. How to find reactions, students? Here we have to find out reactions by taking moment about point A. By taking moment about point A means we have to consider the right side forces to the point A. We have 926, that is PR force, into 926.84 into 400, that is perpendicular distance between point A and B is 400, and here sign is positive because this PR force is acting clockwise about point A. And second force is RCV to the right of A, that is 55. Hence we have to calculate here reactions. RCV into perpendicular distance between point A and C is 800, and here sign is minus because RCV force is acting anticlockwise about point A, plus that P1 plus P2 force, that is 3395.32 into perpendicular distance between point A and D, here it is 1200, and sign it is for this force or movement is positive because that P1 plus P2 force acting clockwise about point A. So let us solve this equation. We get answer for RCV, that is reaction at point C, equal to 5556.40 Newton. Similarly, you have to find out the reactions RAV. How to find reactions RAV? By considering summation FV, that is summation of all vertical forces, is equal to 0. So by considering summation of all vertical forces is equal to 0, we have RAV, one force that is acting vertically upward, plus 5556.40, that is RCV, that we have already calculated, minus 926.84. Here it is minus because this force goes downwards, minus again that P1 plus P2, minus 3395.32, again that 3395.32 Newton acting downward, that's why we take it as negative. So by calculating this equation, we got the answer for RAV, reaction at point A, for vertical loading, equal to minus 1234.24 Newton. Minus sign because the forces at reaction RAV is acting downward. Then next step is find vertical bending moment at point B and C. We have to find the vertical bending moment at point B and C, and we know that at the end points bending moment is always 0. So let us find bending moment at point B by considering left side force. Bending moment at point B by considering left side force A. Here left side force is 1234.24 and perpendicular distance between point A and B is 400 mm. And here negative sign because that 1234.24 force acting about point B, that is anticlockwise, that's why it is taken as minus sign. Then you have to here consider left side force to the B. Then next bending moment at point C, that is bending moment at point C means we have to consider right side forces, and right side forces we have to consider clockwise as a negative, means MCV equal to, here right side force is 339.3395.32 into perpendicular distance is 400 mm. So let us find MCV, that is equal to minus 1358.128 into 10 raised to 3 Newton mm. So this is nothing but bending moment, that is bending moment at point B and C for vertical loading, that is MBV and MCV. Then next horizontal loading diagram. For horizontal loading diagram you have to consider only horizontal forces. So here reactions at point A and at point C are also acting, and at point B on the gear B tangential force is acting, that is 2546.48, that is acting along horizontal directions. So again here let us calculate the reactions at point A and C. How to find reactions at point A and C? First of all, by taking bending moment about point A. So let us consider bending moment at point A. We have plus 2546.48 into 400, that is plus means what? Now to consider here bending moment at point A and direction is clockwise. That PT force into perpendicular distance is 400 into RCH force into perpendicular distance it is 800 and sign is negative because it acts as a anticlockwise about point A. So let us find RCH, that is equal to 1273.24 Newton. Then similarly find summation Fv, that is equal to 0, and find RAH, that is equal to 1273.24 Newton. Then next find horizontal bending moment at point B and C, means we have to add bending moment at point A and D are 0 because these are the end points. So bending moment at point B, that is equal to, we have to consider here left side force, bending moment at point B, left side force, that is equal to R 1273.24 into 400, that is for left side for clockwise it is positive, and bending moment at point C we have to consider clockwise as a positive. So for that is MCH equal to clockwise positive and anti-clockwise negative. And for bending moment at point C means we have to consider here RAH force and that is tangential force PT and perpendicular distance and signs, that is either it is acting clockwise or anti-clockwise. Means MCH, here we got MCH as that is equal to 0. And next resultant bending moment at point B and C means we have to find out resultant bending moment by using equation MB at B, that is equal to under root of MB square plus MBH square. Let us find resultant bending moment at point B and resultant bending moment at point C. And here resultant bending moment at point B is 709.308 into 10 raised to 3 Newton mm, and bending moment at point C equal to 1358.128 into 10 raised to 3 Newton mm. Then next, by taking the maximum bending moment, here maximum bending moment is 1358.128 into 10 raised to 3 Newton mm. Last step is to find shaft diameter using ASME code. We know that maximum shear stress tau max equal to 16 upon pi d cube under root of kb into mb square plus kt into mt bracket square. So into this equation let us put the values of tau max, then kb, mb, kt, mt, and find this equation for d. We got finally diameter of shaft, that is equal to 48.49, that means approximate value of shaft diameter is that is equal to 49 mm. Thank you.